Everyone, this is Shantan Ghosh again. Welcome to Reboot Robotics classes. This time we will be working with Arduino and along with the ultrasonic sensor. In the last two videos, we have seen that how we can integrate Arduino Uno with LED and LCD. This time, for the first time, we are having a class on integrating a sensor, a fully working real life implemented sensor, which sensor you come across, let's say, in every day. When you are entering the shopping mall, the gates are getting open automatically. It's done using this sensor only. In during the Corona time, the COVID period, multiple projects were becoming very famous. That's untouched sanitization. All those projects were done using this ultrasonic sensor only, which actually helps to detect obstacle, and accordingly they can make the robot work. Now let's take the Arduino Uno first. In this session, we will be using an Arduino Uno, one breadboard, so that we can do the connection nicely. We would also need the ultrasonic sensor over here. We will be taking a four-legged ultrasonic sensor, so we can easily search for that ultrasonic distance sensor. So we need this four-legged one. So I would request to delete this three-legged ultrasonic sensor and focus on this four-legged one. Apart from these three, we would be needing some more components. While the class goes on, we will be adding things with this project. So at the very beginning, let's have a small discussion of this ultrasonic sensor. This is the way an ultrasonic sensor looks. It has four pins: VCC, trig, echo, and ground. It has two circular shapes present on top of it. On beneath the first circular shape, its T is written. T stands for transmitter, and on just beneath the other circular shape, R is written. This is the receiver. What actually happens is, when we are talking about ultrasonic sensor, we will have to know about sonar. What is sonar? Sonar is sound, navigation, and range. Now, when this ultrasonic sensor is turned on, it emits rays, ultrasonic rays. This ultrasonic rays goes on and hits on top of the obstacle and returns back to this receiver. So the transmitter is emitting ultrasonic ray. The receiver is receiving it after it gets hit to any obstacle, and when it returns back, retraces back to the sensor. So these are the two things which will be very much vital in order to work on this ultrasonic sensor project, and in order to do any sort of sensing, transmitter and receiver would be very much important. Now over here, the trig pin would actually enable the transmitter to transmit ultrasonic rays. The echo would actually turn the receiver on to receive the ray, which gets retraced back after hitting the obstacle. So at the very beginning, let's start off with the connection. Over here, the VCC is the power section, which would be connected to the 5 volt of Arduino, as VCC is the part which which will actually be powering the entire sensor. So at the very beginning, we are taking 5 volt from our Arduino and putting it over here in this particular column. We are taking the VCC's pin out wire from here, from the ultrasonic sensor, and connecting it into the same line where the 5 volt of Arduino is connected. Now, let's keep both of these in red, as these are the power supply wires. We will be connecting the trig to any of the digital pin. Let's say we are connecting it to 9. We are changing the color to orange. Now, let's say we are connecting the echo now, but before that, let's manage the wire a bit. So now we will be connecting the echo of Arduino. Let's say the echo of Arduino is connected to digital pin. We can take any two digital pins that can be totally of our choice. In this project, we are considering 9 and 10 for trig and echo respectively. As we have seen in our previous classes as well, we need to connect the ground wire properly in order to make the circuit complete. So in this case, we are taking the ground from Arduino and connecting it to the extreme right hand side column of the breadboard. In the same way, we are doing the connection for the ground of ultrasonic sensor as well. Now the connection is done. Now we can rush on to the code so that we can see how we are coding this entire project and what all things we will be starting to do. To the coding part, let's add an LED also, because after the project would get started, we would see if an obstacle comes near to the sensor, the LED would actually indicate that the obstacle has come too near to the sensor. With that indication needs to be done. So in order to indicate this obstacle sensing, we will be using an LED in this case. So from the palette section, let's take an LED like we have always taken. So the ground part of the LED we are connecting in the same column where the ground of Arduino is connected, and we are also adding the ground of ultrasonic sensor. So since we can add any digital pin with the anode part of LED, in this case we are taking the digital 6. So this digital pin 6, which will be the one that will actually get triggered as soon as any particular obstacle comes near to the sensor. So LED is connected to digital 6, ultrasonic strict pin is connected to 9, eco is connected to 10, VCC is connected to the 5-volt pin of Arduino, and all the grounds are connected with the common ground to Arduino's ground. So now we can go towards the coding part. So here is the entire code. At the very beginning, we are declaring the pins for the trig pin and the eco pin. So we have created two variables, trig pin and eco pin, which are actually denoting the trig and eco of the ultrasonic sensor. Since we have connected the digital 9 with trig pin, we have mentioned 9 over here. Since eco is connected to digital 10, we are mentioning 10 over here. So the variable declaration has been done along with the mention of const and in. Const and in data types are used so that we can make sure the computer understands that the values of trig pin and eco pin are constant and they are integer numbers. Now over here, since we will be needing the data of duration, because as we know, speed equals to distance into time. So the time or the durations data would be needed. So we are storing the data by using the long data type, because long data type will actually be giving us more space in order to store the data related to time. And we are searching for the distance to the obstacle. So we are creating another variable in the name of distance with the help of the in data type. So the ultrasonic sensor's initialization part ends over here before the void setup starts. Since we are using another indicator in the form of an LED, we are also mentioning let pin equals to 6. With this let pin variable, we are denoting this LED, and we have mentioned 6 because the 6 digital pin is connected to LED. And const and in are mentioned like always. In the void setup, at the very beginning, we are mentioning the initiation of the serial communication. Serial.begin 9600. As we always know, 9600 is the best frequency at which Arduino works. Over here, pin mode 6 output is actually denoting the LED. 6 is the digital pin with which LED is connected. Output is the nature of the LED device. It's an output device. So we are mentioning output. Pin mode 9, output. It's actually denoting the trig pin and the number of pin it's connected to. Since trig pin is making the transmitter emit the ultrasonic rays, it's acting as an output from output device because it's giving some output in the form of ultrasonic rays. Pin mode 10, input. Here we are mentioning the eco pin with the digital 10, and we are mentioning input over here because receiver part is getting triggered, and with the help of eco, we are gaining some knowledge from the surroundings. That's why, since it's taking some input, we are mentioning pin mode 10, input for eco pin of the ultrasonic sensor. Now over here at the very beginning, there is a rule in order to start the sensor's working functionality. We make the trick pin low for 2 microseconds, and accordingly we have coded over here. We have mentioned delay microseconds. For 2 microseconds, the trick pin would be low at the very beginning. That's how we have coded the first two lines of our main code, which is present inside the void loop. Now, after this, we are seeing that digital write quick pin comma high for 10 microseconds. These are the two code line of code which is actually triggering the ultrasonic sensor to transmit the ultrasonic rays from the transmitter. After the emission has been done, the ultrasonic ray would be searching for the obstacle where it can hit, trace back. So for 10 microseconds, this ultrasonic ray emission is going on. After that, trick pin would be made low. This line is very, very important. If you miss this line, the output would come as distance equal to 0. We need to make the trick pin low. We need to make it stop after 10 microseconds of ultrasonic ray emission. So now we are following the basic formula of physics. Duration equals to pulse in echo pin high. Over here, we have made the echo pin high in order to make the receiver part triggered. Now, as soon as the receiver part is triggered, it will be actually taking the input from the surrounding. It would take the emitted ultrasonic ray back in order to get the information how far the obstacle is present at the current scenario. For this, the pulse in command is actually helping us by converting that data so that the duration can be easily got, durations data. So from distance, from the time which the ultrasonic ray has taken to go and come back after hitting the obstacle sensor is converted and stored inside this duration variable, which we had already declared at the very beginning of the code. So the data that is there inside the duration variable would be used over here in the next line only, where we are using the basic formula of physics, distance equal to speed into time. Over here, 0.034 is the speed of ultrasonic ray. And we are mentioning the time over here as already on the previous line, we have received the data of how much time it was taken by the ultrasonic sensor to return back. Now, over here, since the ultrasonic rays are traveling from transmitter to obstacle to the receiver part, since it's covering this entire distance from the sensor to obstacle twice, we are dividing the data by 2 in order to get the exact figure of distance, how far the obstacle is present. Again, I will repeat, since the ultrasonic ray is traveling from transmitter of the sensor to obstacle to receiver of the sensor. Since the journey has been done twice, we are dividing the coming outcome value by 2 in order to get perfect distance, how far the obstacle is present from the sensor. Now, we have coded the LED in such a way that if the obstacle is less than 50 centimeters from the ultrasonic sensor, the LED should go high. If the obstacle is not present within 50 centimeters from the sensor, the LED would not glow. And we would also be printing the data, how far the obstacle is present from the sensor. That would also come in the serial monitor. So let's play the code and see how our project is working. So there are some issues over here in the error part, compilation part. So at the very beginning, let's check that and we will be solving this today. In this session, we will be actually working on error handling also, which we have not done yet. So let's work on. So over here, we have fixed the problem in the code and we can see that our project is fully ready. We can click on start simulation. And over here, what we had done a mistake is we were not giving these semicolons over here. If the semicolons are not given, we can't tell the computer that the coding line has ended over there. Let's say the first line is getting ended over here. So a semicolon is given. So it would not get confused with the second line. Second line is getting ended over there. So semicolon needs to be given. And whenever we are mentioning print, the P should always be in small. So let's start the simulation. As you can see, the LED is glowing. So let's see, yes, the obstacle is present within 50 centimeters, that is mentioned over here, as you can see. So if we take it upward, let's say it's 61 now. This is the obstacle, the circular ball. It's present 61 centimeters away. So the LED is not glowing. Let's say if we take it inside 50, see 43 centimeters, then the LED is glowing. That's how. If it's 108, the LED is not glowing. If it's 26, within 50 centimeters of the checking area of the sensor, the obstacle would be detected and the LED would also. So that's the entire code that we are working today. So let's have a small recap again. At the very beginning, ultrasonic sensors initializations have been done. Pig and echo are connected to 9 and 10 digital pin. We have already declared the variables like distance and duration, and also LED pin in order to mark the 6 pins connected LED. After that, in the void setup, we have mentioned all the pins that are connected 6, 9, and 10 along with their nature. In the void loop, we are mentioning the main code, how to start the ultrasonic sensors detection process, and if the obstacle is present within 50 centimeters, what would happen? We have also mentioned that. So accordingly, the LED is actually giving us the indication that if the obstacle is present within 50 centimeters, it would glow on. If it's away of, it's beyond 50 centimeters, if its presence is beyond 50 centimeters, it would not glow on. So thank you for the session. Here we end the session on Arduino and ultrasonic sensor. Thank you.